RTO, a specific crop ontology for rice trait concepts. We will introduce our project from 6 aspects. First of all, we have got 3 points in the introduction part. The quality and the consistency of agricultural data has improved since the use of digital technologies applied to the research, especially at the standardized ontologies turn. Our project aims at collecting rice trait concepts among plant ontologies, developing an integrated rice trait ontology, and providing data service for related researches. Secondly, the necessity of a project. We found that the quantity of PubMed rice literature from 2000 to 2022 are shown in the figure. As you can see, the amount of rice-related literature is rising. With more and more researches on rice in recent years, it is necessary to construct a rice trait ontology. There has been some studies on crop trees, such as plant trait ontology, plant experimental conditions ontology, phenotypes qualities ontology, and so on. We focus on the plant trait ontology, PTO. PTO is a controlled vocabulary to describe phenotypes trait in plants. It has 1,554 items, and each item includes the information like class ID, preferred level, synonyms, definitions, obsolete, and the like. As the table shows, plant height is an example. Here's a question for you guys. We already know the plant trait ontology, PTO, but why we still gonna build the rice trait ontology, RTO? First, rice has many specific traits that do not apply to other crops. The PTO does not, such as periculary leaf spot, false smut, and so on. As there is no unified standard for rice trait, which hinders the development of research, it is urgent to establish rice trait standards. Ontology specific for crops has also developed. For example, wheat. Recently, the wheat trait ontology, WTO, an ontology started developing in 2010 and aimed specifically to wheat trait and phenotype information. Unfortunately, there is no specific trait ontology for rice still now. Therefore, it is necessary and feasible to construct a trait ontology for rice. In recent years, there has been an ontology called CO320. It provides description of agronomical, morphological, physiological, quality, and so on. According to statistics, CO320 has a total of 1,438 items, including 405 variables, 268 trees, 364 methods, and 401 scales, among which there are more detailed subclassification on the trait, method, and scale. For example, there are computation, cutting, estimation, and measurement on the method. The web page of CO320 also provides the knowledge map of rice ontology. When a certain rice trait is selected, its related items such as method and scale can be visually displayed. For example, when we choose plant height, related information is displayed on the right. As shown in the figure, its parent node is morphological. The related method is plant height variable and plant height measurement, and 2 related variables. On the basis of above research, we built the rice trait ontology, RTO. Next, let's talk about the RTO construction. In addition to the PTO mentioned earlier, we further researched several ontologies with the crop to construct a more complementary RTO. We have already merged the WTO with PTO and finished the first version of RTO. Now, we would like to introduce the detail of our RTO 1.0. We have already known that the PTO includes the normalized plant trait conception, while WTO includes the wheat trait conception and the environment condition. Next, we will introduce specific strategies of our ontologies integration. We complete this work from three aspects: merge, add, and delete. First, the merger strategy. If the WTO term has the same term as TO, then we mapped it to the corresponding TO term along with the original WTO hierarchical structure. We merged 75 nodes totally. Second, the add strategy. Add the term related to rice trait in WTO to TO and keep its WTO ID and try nodes. We successfully add 180 nodes to TO. Third, the delete strategy. If the WTO term is not related to rice trait, then we delete it. We totally deleted 63 nodes of WTO term. Now, the RTO 1.0 version has completed. It includes 2041 rice trait concepts now. RTO is mainly divided into plant trait and environmental condition. The plant trait part of RTO mainly inherits the structure of PTO, while the environment condition part mainly inherits the structure of WTO. Plant traits include Class Is, biochemical traits, plant growth and development traits, stress traits, and so on. Environmental condition includes biotic condition and abiotic condition. You can download the RTO file from our web. Compared with CO320, RTO was not involved in the research method of trait, but in terms of the number of rice traits, RTO was much higher than CO320. In construct, RTO is more detailed in describing rice trait. In order to provide easy vocabulary browsing and external links of RTO terms, we have launched a user-friendly web page. Let's watch a video. The basic information of RTO terms, including term ID, name, definition, and relationship. Have the cursor to retrieve omitted information. Click the logo on the left of the navigation bar to quickly return to the home page. More information and external links of the term can be found on this page, for example, comments, synonym, further notes, and so on. And the external links of PubMed provides a quick search of PubMed to help target literature reports related to these rice traits. The search box with a recommendation function is used to target the interested term. The web page provides keyword search and process trait search, and the recommended words adopts the name data in RTO. The RTO fields can be also downloaded from the web page. Furthermore, there are still some work needed to be continued. First, there are other ontologies that may also include rice trait concepts. We are planning to add fungus gene and CO320 into future 2.0 and 3.0 version respectively. Second, although the RTO is already covered most of the rice traits, with the development of rice research, more and more rice trait concepts will need to be integrated into RTO. Third, RTO can be used to guide the knowledge discovered related to rice traits, such as manning their relation with genes. In summary, the construction of RTO provides a standardized terminology set of rice traits, and which benefit for normalization and application of rice trait in various studies. Meanwhile, the knowledge discovered based on RTO will serve to automate rice knowledge mining and experimental guidance of rice breeding. That's all. Thanks for listening.